Hello and welcome to the Oxford MAT Livestream. This week on the MAT Livestream, geometry. Hi to everyone who's joining us now in chat underneath. If you want to join chat as well, you can do that over at slido.com/matlive. Let's start with some maths. So geometry puzzle. Sometimes you've got a circle and you try to draw a line through it. Maybe you're trying to draw a semicircle, but you miss. So you have this line going through a circle, so that you've got this area here that is not a semicircle. We tried our hardest, but unfortunately not a semicircle. The geometry question we could ask is something like, what's this area? You might have some formula in mind for the area of a semicircle, but here it's a little bit more complicated because there's no sort of simple formula for that. I've got more of a suggestion of how we might have a method to work that out, which I'd like to run through with you all very quickly now. So here's my sort of strategy for finding this bit of area, which chat has told me is called a sector, possibly. I'm pretty sure it's called a sector. Let's join some dots up to have some radii in here, some radiuses between here and here. If we knew the angle theta at the origin there, yeah, we could make a triangle with between two radii. If we knew that angle theta, then we could work out the area of this triangle here and the area of that sector. And George has even put a formula in terms of theta in chat, which I'm going to work out now very quickly. Okay, here's a kind of method or possibly recipe, depending on how you feel about recipes and methods as a general kind of set of things. Step one is going to be find the points of intersection. So your mileage may vary. I haven't given you the equations of the circle or the line or something, but if I call these A and B, find the points of intersection A and B. Find those. Let's zoom in very slightly. There we go. Step two is going to be find theta. This could be perhaps, this could be with the cosine rule. So actually, how are you going to find those points of intersection? I suppose we've got a line and a circle. If we write down equations for those, that's a linear equation and a quadratic equation. So this is maybe quadratic formula or something. I'm going to put maybe quadratic science in there for the kind of general science of how you solve quadratic equations. Find theta, and then once we know theta, we're going to do segment. I've got all my segment and sector words mixed up. Segment minus triangle. That's going to be, so the segment is something like theta out of 360 degrees. It's that much of a circle times pi r squared. That's my segment. So my segment is theta out of 360 degrees. Pi r squared, because that's how big circles are. That much area minus the area of that triangle. Last week on the Oxford MAT Livestream, we had the area of a triangle like that to be half BC sine A for the angle in between. Here that works out like that, which is all very nice. Both of these got an r squared in. If you use radians for your theta instead of degrees, then the numbers are slightly different over here. I think you put a 2 pi down here instead, and then the pi's cancel out, and you get I guess you get a 1/2 in both. So this is theta in degrees. I feel like using degrees today. Okay, and that's some sort of strategy. Don't learn this. Don't take away from this a formula. Don't learn this, but remember the methods. Remember the steps of how you might go through the strategy of breaking down that area into some steps and then putting it all together again. Hi chat, how's it going? So we like to start with maths on this live stream to encourage people to be here at the start of the live stream. Is it sector minus triangle? Oh, what's a sector, what's a segment? Have I gotten confused again? I might have to look up sectors and segments. Yeah, cool. Good. Okay, so classic for the MAT Livestream. People are asking questions in chat as well. Today I'm going to do kind of the MAT Livestream bit with Matt for the first hour. So I'm going to do some maths with you for some geometry, 5 o'clock to 6 o'clock, and then I'm going to take all the admissions questions. I'm saving them. You only have to ask it once. I'm saving them. I'll come back and do them at 6 o'clock. So this is a question about discriminating against A-level years, which obviously we're not going to do, but you know, at 6 o'clock I'll say in great detail we're not going to discriminate people for being born this particular year. Right. Is a sector the pizza-shaped bit? A sector is pizza-shaped, says Zach in chat. Let me do a very quick. What do we think? Sector start of the circle? Oh, segment is the thing over there. Right, okay. I've confused. There we go. Not a great start to my geometry hour, but there we go. I'm going to put sector in there. Cool. Good. Okay. Shout out to people in chat as well who are joining us. You can be anonymous in chat, or you can put your own name. Yeah, shout out to everyone who joined earlier. I hope everyone's doing well. It's the middle of the summer holidays now, I guess. So here we are doing some maths. What's that like? Oh, we do a poll at the start, don't we? So I've got a star poll for geometry. We've been doing one of these each week for how we feel about the bit of maths that we're about to talk about. This is a rating and a 5, and the first 2 votes there, 1 and 5, closely followed by a vote for 3. 5 stars would be, I love all this stuff, circles and lines and geometry in general. I suppose the sort of geometry that I want to really think about today is that the kind of start of A-level sort of geometry, things like coordinate geometry, maybe lines and circles, basic properties of circles, things like that. People are going for a lot of 4s in there as well. There's a good question. Behind the poll at the moment, there's a good question. Can you combine together geometry and integration? And that's actually quite tricky to do on the MAT, because on the MAT, you can't integrate very many things. There's an integration session coming up in about 3 weeks' time, where we're going to talk about integration. And that one is going to have the integration in. Lots of things that you can't actually integrate using MAT integration. So it's actually quite hard to do that kind of crossover synergy sort of question. But they both involve finding areas. So there's something good there, I suppose. Maybe some sort of geometry integration question. What could I do? You could have a parabola with a circle that you have to subtract. So then I'm testing integrating a parabola and subtracting a circle. You're watching that mashup question writing stuff live on a MAT live stream. How's everyone doing? You alright? Good. Right, okay. Yep, okay. So this one's come out as 3.6. I'm letting it settle a bit as people vote about how they feel about geometry. It's 3.6 because that distribution there of star ratings, this is my data analysis observations, the distribution looks kind of similar, except for the huge number of people who have voted 1 star hate geometry. Thanks for joining us, obviously. You've done the right thing by clicking on a video called Geometry if you hate geometry at the kind of 1 star out of 5 TripAdvisor level. Yeah, it's gone down to 3.6 now. Ooh. Right. Geometry is a weird topic. And I suppose today we're doing mostly coordinate geometry sort of things, rather than Euclidean geometry. There's a question behind the poll for people watching live. Rather than Euclidean geometry, people learn lots of Euclidean geometry in school. I guess we know some of it in the kind of basic properties of circles. There's some Euclidean geometry facts from GCSE or equivalent hanging around in there. Okay. Yeah, so Euclidean geometry is all the stuff you do with on a 2D plane, all the stuff you do with circles and right angles and things turning out to be, you draw a triangle in a circle and then the angles are the opposite angles, all of that stuff. I've got some of it in the revision section, which I'd like to look at now. So I'm going to turn the poll off. Thanks for voting in the poll. Oh, that's up to 16% at 1 star. Oh, that's high variance, right? We should work out the variance of our poll ratings afterwards. Cool, thank you for voting. Oh, one more, there we go. Good. Ellie, question. Do we need to give answers or working in... Will we need to give answers or working out in radians or degrees? So the answer to this, which comes up a bit, trigonometry last week as well, is that all the questions are going to be asked in degrees on the math submissions test. You can use radians if you want to. You'll need to translate the questions from degrees into radians, but you're welcome to use radians if you want to, in your working out or in your answers. We do degrees in the questions just in case people don't know about radians or don't like radians. Okay. Really like geometry, less confident in it than in other areas of maths. Okay. So I'm going to try and do some bits of geometry today. Geometry is actually a really deep subject. If you come to study maths at university, then you find out about lots of other stuff under the heading of geometry. Loads of more interesting spaces and shapes where you might do some geometry. Everything we're going to do today is sort of in a nice 2D flat environment where we're looking at everything very nicely, and we're mostly going to be thinking about circles and straight lines. Common strategy that we're going to do today is translating geometry problems, circles and lines and stuff, translating them into algebra problems, because we're really good at algebra. We know loads of techniques in algebra. So I guess my main strategy here is going to be take geometry questions, convert them to algebra, do algebra. At university, there's something called algebraic geometry, which is all about the intersection between turning geometry problems into algebra and also turning algebra problems into geometry. Good. Do you need any geometry equipment? So you don't need any geometry equipment. I think you are allowed to bring geometry equipment with you. That means protractor and a ruler if you want to, but I don't think it's going to help, and I don't think you need it. We write the questions without assuming that you have access to a protractor or anything like that. It'd be quite a boring question, wouldn't it? Measure this angle with your protractor? Oh, who's got time for that? And somebody asking me about PAT, which is the physics aptitude test. Physics aptitude test involves a chunk of mathematics as well. I think not quite so much geometry as the math submissions test, but who knows? This sort of problem solving, turning things into algebra and solving algebra questions feels useful to me. Right, cool. And a question about applying what we've learnt from one question to another question, which I'm going to try and do because we're going to do some similar looking questions. So I'm going to try and very directly apply what we've learnt from one question to another one. Okay. I've got a reflection section in the solutions. The solutions get posted the day after the live stream. So if you're watching back, then they might already be up on the MAT Live website, down at the bottom there. There's a reflection section at the bottom where I think about links between questions and think about what I've learnt by doing the questions. I didn't know I was going to do that when I started writing them, and then I thought it would be nice to put some reflection in. So who knows? Thinking about links between questions is good fun. Right, okay. If you want some revision material on vectors, then I've got some on screen here. I'm not going to talk about vectors today. I just picked out some questions that don't involve any vectors. For math, you don't need to know very much about vectors at all. You can add vectors together. If you do that, then you get the sort of displacement from one position vector to another one. So if you add a vector to another vector, you could think of that as being the journey from A to B to C, like this. So you might have a vector for this bit and then a vector for that bit. You can add them together to get the journey of where you've been. But when you actually add them, you don't think about that at all, really. If you're adding two vectors, you just add the numbers together. Good, right, okay. Good. Distances, magnitudes. Yeah, the thing I want to talk about, I think, some straight line stuff I've put on the revision section as well. Facts about straight lines, different ways to write down the equations of straight lines. I've got at least 3 that I could think of. Maybe people in chat can think of other equations for straight lines. There's this one, which I think is the first one I learnt, y equals mx plus c. I like this one because it's got y on the left, so it looks like a function. It looks like y is this function of x. What I learnt later on, I think I was doing lots of A-level problems, and this form was really useful for doing the sort of A-level problems I was doing. If you know a line goes through the point x1, y1, then you can use this form, and it just magically goes through the point x1, y1. So that might be helpful. There's also this equation, ax plus by plus c equals 0. Sometimes people write this one as ax plus by equals c, in which case that's a different c. But these are kind of morally the same way of writing an equation of a line. That was actually really interesting because you can modify that one in quite a simple way. You can modify it to make it into the equation for a plane. We're not doing any planes today, just sticking to 2D stuff. Scalar product in A-level maths, but that's in Russia. So, yeah, no scalar products today. There's secretly a scalar product hiding in that last equation that I put a box around, but you don't need to know what a scalar product is today. Continuous random variables, okay. Good. Oh, other suggestions. Oh, people have got vector suggestions. Why did I not think of this? People have got suggestions. And look, 2 people have got basically the same suggestion. Wait, maybe that's the same person twice. Who knows? With vectors. I like that. I like that so much. I'm going to write it down over here. So also, what am I going to write? I'm going to write something like, I'm going to write vector x is equal to vector A plus lambda vector B. I think sometimes people write R for the position instead, but I can't really say that letter, so I'm using X. Vector A plus lambda vector B. That works nicely if these are all vectors. Okay, yeah, that's a good expression if you're happy working with vectors. Lambda is some scalar that you vary, so it sort of says start at A and then go in the direction of B, using lambda to decide how far you're going, either positive or negative. Good, yeah, and somebody's called me out for saying morally, but I kind of mean it. Yeah, equations of lines depending on theta. I think that one, so looking ahead, there's an equation coming up over here somewhere, going sideways through the paper, with some thetas in it. I think that's pretty much the ax plus by thing. If you move this term onto the left, it looks like ax plus by to me, with some weird constants going on. Okay, we're going to get to that when we get to that. Okay, I like that we've got other forms of writing lines coming in. B's here, hi B. People talking about efficiency of calculating things with computers. Our scalar products is another name for dot products. We had an episode of the Oxford Online Maths Club about dot products and scalar products. So if you've heard us say that quite a lot and you want to find out what that is, there's an episode called Dotty Maths. I think it's season 2, episode 8. So if you want to look that up, lambda is some number, so it's sort of scalar. It's a number, and it's between. This is going to annoy people. Between minus infinity and infinity. As you change lambda, you get different points on the line. You don't have to use this form of writing down lines if you don't want to. Good. This one is. This is a good point that I've thought about quite a bit since we started doing these live streams. There's a question in chat. Are we meant to finish the worksheets before joining the live stream, or are we meant to work on the worksheet while we watch the live stream? And I reckon that some people are doing one and some people are doing the other. So I'm trying to make the live streams work whether you've looked at the worksheet or not. If you look at the worksheet in advance, then you can have time to try everything. If you just join in during the live stream, then I'm skipping lots of stuff. So I guess ideal strategy is probably something like look at the worksheet before, read it, maybe try bits of it, and then during the live stream chat about what we're doing and maybe get some hints for how to do stuff. Okay, we've got some circle facts. So earlier somebody asked about Euclidean geometry and stuff that you learn at GCSE in the UK or equivalent elsewhere, I think. Things like Thales' theorem, the angle in the semicircle is a right angle. If AB is the diameter of a circle and C is on the circle, then the angle ACB is a right angle. There we go. What a great picture. Even if I say so myself. Okay. Angle in a semicircle, I like that one. There's a tangent which is at right. The tangent's always at right angles to the radius. The picture you normally draw for this one is radius, tangent. Those are at right angles. I like that fact as well. And up here, area and circumference of a circle. Okay, easy stuff about circles. Right, those here too. Yeah, the classic MAT Livestream question, of course, is what happens if lambda is complex? I've learned that people watching the MAT Livestream love complex numbers. They want everything to be a complex number. They like taking normal things and making everything into complex numbers. I don't know what happens if lambda is a complex number. I guess the output is a complex number as well. There are no complex numbers on the maths, but it's something that I can tell everyone's very interested in. Okay, warm-up problems. So, if you want to practice doing stuff with vectors, you can do some practice problems up here. Here's another one. So, maybe work out... here's another one. If you've just seen that formula for the equation of a line for the first time ever, I'd like you to work out what this is, and then plot those points for all values of lambda. So as lambda changes, what sort of points, x, y, what sort of position vectors can you get out of this expression? If you've seen that material before from A-level maths somewhere, then it's not an exciting exercise for you. But if you just saw that a plus lambda b thing for the first time, here's a thing to try. I love chat so much. What is this? Yeah, Ocean's heard about quaternions, so now we're talking about quaternions. Lovely stuff. Complex numbers are brilliant. Okay. Well, what about it if it's a matrix instead? Yeah, see. I like the way those all queue up in the chat. We mentioned complex numbers, and then all the quaternions, matrices, other stuff all comes in at the same time. Oh, people are working out the equation of the line. Nice stuff. Look at this. People are doing the mathematics as well as the memes. Very impressive. Yeah, so people are working out the kind of gradient of the line. And people think this is a line and they're working out the gradient, or even the equation of the line. Brilliant stuff. Right. Yeah, what's a quaternion? It's like a complex number, but more so. They're a little bit like four-dimensional complex numbers, but that is not actually a good description. It's complicated. They don't work in the same sort of way as complex numbers. I don't want to talk about complex numbers. I talk about complex numbers every week a little bit, even though they're not on the mat. So why are they on the MAT livestream every week? Right, okay, skipping all the vector stuff and finding equations of lines. Boring, boring, boring. If you want to practice this, then there's the warm-up material there if you can look at it. I guess you can look at it before the live stream, during the live stream, or after the live stream. What's the area of this circle with radius 3? Okay, I want to talk very quickly about this sequence of 3 problems that I put on the warm-up, because they build up to a problem that I quite like. The third problem here is really quite hard if it just turns up and you weren't expecting it. We're given 2 circles and told to find the area that's inside both circles. We did a little bit of this on one of the Maths Club episodes, I can't remember which one, and it was really tough to work out in general what's going on when you have 2 circles that intersect. Here the picture is nice and symmetric. So if you look at these 2 circles, maybe you've had a chance to look at them before, but the left one there is a circle with centre at 0 and radius 2. And the right one has also got radius 2, the same size, but it's at centre 2, which is brilliantly on this circle. So they kind of go through each other's centres. Oh, and I've drawn them not the same size. That's terrible. Let's do that again. Just draw a circle. What is wrong with me? First time. Good. Good. I'm catching up with chat. Oh yeah, Zach's trying to define quaternions in chat. Very brave indeed. Have you got powers to work? B's got powers to work. Look at that. Do those work on screen as well? Oh my word, you got those tiny little 2s. Amazing. And we're doing lines again. Oh, look, equations of lines. Brilliant stuff. Here's a Venn diagram. Yeah, it looks like a Venn diagram, right? There's a Venn diagram where I'd like to know the area of the stuff that's inside both circles, which is maybe the most Venn diagram question to ask, right? On the Venn diagram, which indicates the intersection, how big is the intersection for this particular Venn diagram? Okay, they're not quite... Yeah, so concentric normally means something different. Concentric normally means they have the same centre. I don't think there's a word for this where they share, they both go through each other's centres. It's quite a nice setup, isn't it? And they meet at, this is radius 2, so they meet at x equals 1. Which is nice and pretty and lets you work out lots of things about where those points of intersection are. And now we can follow the recipe that we had before for working out the areas here. If I mark in this little bit of area, then that's a bit of a circle, pizza slice of a circle, minus a triangle. Yeah, you can work out the line through the 2 points of intersection, which is x equals 1. Yeah, we should draw in lots of radii lines. We draw in some radii lines. I'm trying to draw pink on top of pink. There we go. Drawing some radii lines. That's tiny. Let's zoom. There we go. If we draw in some radii lines, then we get this nice little picture. We can think about chunks of circles and triangles. Do lots of addition and subtractions. Oh wow. Okay. It's on a phone keyboard. Wow. Right. Catching up with chat. The previous 2 questions I've added in there to walk you through the steps, so that once you've realised that about this picture, you've already done some of the calculations for working out what the area is in between. The angles are really nice. So how do you actually calculate that area? So it's the area inside both circles is double the pink area. I've zoomed out again. Why have I zoomed out again? The area inside both circles is double this pink area. This pink area is just what happens when you have the line x equals 1 crossing the circle x squared plus y squared equals 4. Let's mark it in again. And that's not too bad to work out. So recognise that this thing's nice and symmetric, so I can just double one side of it. This dip's not too bad to work out because the angle's really nice at the origin. You know where everything is, you know where these points are, so you can work out some angles. The angle turns out to be nice. It turns out to be 120 degrees, which is why there's 120 degrees up here. 120 degrees, that's very nice. It's all about 1/3 of a circle minus some stuff. Okay. Ah, never mind, just understood. Some person in chat before I said any of that. Cool. Yes, maybe we should draw Venn diagrams so the areas are proportionate. Could you integrate here? So here's a really good question. Could you integrate? No, that's a good question. Could you integrate? And it's a sort of personal question as well. Could you integrate? Define that. Depends how happy you are integrating really complicated functions. So you could flip this over sideways. You have a circle, flip this over, you've got some function now. This is some function f of x. As you change x, if I rotate this round, you want to find the area underneath, so do some sort of integration. The function's pretty nasty. And if you're really great at integration, then you can do that integral. You can go for it. You're not expected to be good enough at integration to do that when you come to do the maths submissions test. So I'm not going to do that integration now. If you're super keen on integration and you've seen lots of it in school or college or A-levels or equivalent, then that's, I guess, a challenge to work out this area again, but using integrating of a bit of a circle. It's not straightforward. You have to do some complicated integration tricks. Okay, good. Am I getting confused between 2 questions? No, all 3 questions are secretly like the same question. They're all related. This thing turns out to be exactly the same setup as the one before with a line x equals 1, and that turns out to be exactly the angle 120 degrees at the centre. So they're all different steps of the question. Could you do it with 2 integrations? Yes, it's twice as much integration. Yeah, and I'm doing complex integration in the sense of, just to make it clear, complex integration in the sense of very tricky, not in the sense of complex numbers. Right, okay, we're going to look at a math question. I'm going to put a poll on for this one. Yeah, here's again the intersection between geometry and integration. I put a hint on this one to do this like a geometry question, not like an integration question, even though it kind of reads like an integration question. Anyway. What am I doing? I want to turn on a poll for this one. Okay. So it's going to hide chat as well. Yes. And somebody says I keep saying A-levels or equivalent, and that's because I know that not everybody's doing A-levels. And if I don't say or equivalent, then I'll get questions. Is it square root 3 minus x squared? I think it is square root 3 minus x squared. So then the question is, can you integrate 3 minus x squared, George? It's a tricky integral. I mean, it's something you learn to do at some point in A-level, but maybe not by the time you do this test. Anyway, here's a MAT question on the screen. It's MAT 2013, question 1H. The question is, the area bounded by the graphs y equals square root of 2 minus x squared and x plus root 2 minus 1 y equals root 2. So that's two crazy graphs. And that equal, which of these is that? Is it sine root 2 over root 2? Is it pi over 4 minus 1 over square root 2? Is it pi over 2 root 2? Or is it pi squared over 6? Hashtag Euler. Let's see if I can fix this. This is sort of... There we go, that's a little bit better, isn't it? Made chat the right size. Okay, so goodness me, this looks pretty tricky, especially the first time you see it, I think, because it's two complicated graphs, mixing up things that we learn in time for math. When did I mute? I'm so sorry, I muted, and I don't know how long ago I muted. Let's rewind a bit. So here's a math question. Yeah, like 20 seconds ago. Yep, good. And chat's now got a 20-second lag. Hi everyone, we're just waiting for chat to catch up. I'll talk. Here's a math question. It's math 2013, question 1H. We're asked for the area bounded by the graphs, square root 2 minus x squared, and x equals root 2 minus 1. Y equals root 2, which there's got lots of root 2's in, which makes the root 2 option look very tempting, but we're going to work this one out. Sac refresh just as the muting stopped. Sorry everyone, I was paused for about 20 seconds, but chat helped. If you're watching the replay, then annoying, I might cut that out. Who knows? Right, cool, nothing happened. Anyway, hi. So I kind of want a strategy for how we might work out what that area is. Todd shouted circle in chat. Thank you, Todd. And Georgia said semicircle, which is even better, because I think what you've both spotted, if I put the equation in, is that this equation over here is something like y squared equals 2 minus x squared, which would be a circle, x squared plus y squared equals 2. It's not quite all of the circle. Doesn't actually matter for this question, but it's not quite all of the circle because this square root thing is only positive, so it's just the top half of the circle. That turns out to not really matter for the question, but never mind. Okay, so this is one of the graphs, this semicircle that goes, I guess, from minus root 2 up to root 2. Cool. The second equation looks horrendous, and B is worried that we might need to sub it in. First time watching live. Hi, first person time watching live. Nice to see you. I stumbled over that sentence as well. Maybe it's better when I'm muted. You can't hear the nonsense that I'm trying to say. I think B, we might need to sub these equations into each other. We might rearrange them a bit first. We might try and be a bit clever about it to try and minimise how much work we're doing. But I think we are going to look for some intersection points. Especially if we can find some good points that are on both lines. Maybe we could just guess points that are on both lines. Both graphs. Yeah, semicircle without the bottom half. Why is there a hashtag Euler on pi squared over 6? The option D might be a joke answer. I'm not really sure. I think it might be a joke answer. And the second equation, people are telling me about the second equation, is a straight line. So people are telling me in chat, let's have a quick look at chat, just so that, hang on, I'm going to turn the poll off and on again so that people watching the replay can see how clever chat is. Look how clever chat is. They're all saying points where the second line is. They're telling me it's a line. Chat's really good. One day I'll work out how to have chat and polls up at the same time. And then we're going to use the recipe. We're going to use the sector segment thing recipe. I might even learn which way around sectors and segments are. This line is brilliant. It goes through root 2, 0, which I guess you can spot if you're looking for points that are on this line. You might look for the y-intercept and the x-intercept, or you might just think, oh, I hate this term with the brackets. I can make it go away if y is 0. Let's think about what happens when y is 0. When y is 0, this bit vanishes, and I'm just left with x equals square root 2. So I can discover this point on the line like that. Or maybe just you like finding intercepts of things. The other intercept is going to be really tricky to work out. Well, not tricky, but it's going to be something like root 2 divided by root 2 minus 1 or some mess like that. There's another point of intersection. Fermat's massive theorem in chat. I guess that's the opposite of Fermat's little theorem. Fermat's massive theorem, and also Anish and some other people, Zach has pointed this out as well. It also goes through 1, 1. Kind of interested in how people spot these points. So it's true, right? 1, 1 does work. 1 plus root 2 minus 1 times 1. That all adds up to root 2. I'm kind of interested in how people spot that. It makes the question much easier. As soon as you've spotted the point 1, 1 is on both curves, and it is on both curves, makes the question much easier because now we've got our intersection points. Like that. It's this line. We're basically done. Well, we're not quite done, but we've got a strategy now, once we've sketched both. How do people think of 1, 1? Oh, and he's actually equated them. Okay, so there's an actual algebra approach would be something like, take this expression for y, plug it in here, rearrange, solve everything, solve for x, or something like that. I guess you could do that. I guess you could take this expression for x, you could plug it into this expression up here, hope that the quadratic's quite nice, get a quadratic out. I guess if you really love quadratics, then you could do that. The question is, how did you spot that 1, 1 is on both curves? How do you spot that? I guess there's a slightly sneaky way that you can try other values of x and y, just sort of guessing integer numbers, guessing whole numbers for x. Did anyone try this? So someone anonymous tried x equals 1 to get 1, 1, just to see what would happen. So if you kind of stare at it, then maybe you could spot that there's a root 2 here and a root 2 here. I can make those balance if I take y to be 1, and then they're kind of in balance. So that kind of looks like it'll be a nice value of x, because if I put y equals 1 in, then the root 2's will go away. I'll have a root 2 on both sides. In fact, I think that might be the only nice value of y, where the root 2's go away. And then once the root 2's have gone away, I'll get some nice value for x. And maybe you could explore it like that. Without doing trial and error, I would plug these equations together. This is just some equation for a line. This is an equation for a quadratic. I would rearrange this one for x, substitute it into this quadratic. I'll get a quadratic for y. I'm great at solving quadratics. Don't really want to do it live, also because it will be really messy, but it's a quadratic for y with 2 roots, 0 and 1. It's quite a nice quadratic actually, isn't it? Maybe that'll be good. How long are we supposed to take? Maybe 6 minutes to do a short question. You don't have to do each question in 6 minutes. You get 2.5 hours to do the entire exam. You can split up the time however you like. Zach did guess key values as well. Geometry's confusing, says someone. I guess we're not really doing any geometry yet. We're just doing some sort of algebra to work out points of intersection between these two curves. I think that's just algebra. And we've got strategies about looking for values that solve both of these, or satisfy both of these equations. We've got different strategies like turning it into quadratic equations, but we've also got this kind of strategy of guessing solutions and sort of knowing, wow, we've got 2 and that feels like enough solutions to this. How do you work them out without guessing or loads of algebra? It's a really good question that someone's just asked. I'm starting to think that the algebra is not that bad. Am I going to do the algebra? I don't really want to do the algebra. I'll give the algebra a go. Give the algebra a go. Am I going to regret this? I might regret this. Okay, so I'm just going to take y squared equals 2 minus x squared. That's my starting point. That's the quadratic on the left. And I'm going to sub in this expression for x, which is just root 2 minus 1 y. That's squared. I'm going to multiply this out, which is not too bad at all. I can already see that 2 is going to cancel, which is going to be lovely. Just lovely. Root 2 minus 1 y plus, what's this term here? So this is, I mildly regret this, but not a lot. I'm having some fun, but not a huge amount of fun. Okay, so I've now got a quadratic. The 2's cancel, so it's going to be y equals 0, or y equals something else, where I'm going to need to rearrange these. I guess I'll multiply out these multiply out these terms in here, I've got an extra y squared. So this is going to be 2 minus 2 root 2, and this is also going to be a 2 minus 2 root 2 kind of thing. So those will cancel, and I'll get y equals 1. Okay, so the algebra is not too bad, actually, to kind of solve for that point. Anyway, moving on, we've got to find this area. We've got to find that bit of area. It's just like the questions we've been talking about before, where we're going to find that area by writing down a triangle, writing down the radius of the circle, finding that angle. It's 45 degrees, or pi by 4 radians, because that's the angle between the x-axis and a line going up through 1, 1. 1, 1 is kind of a 45 degree-ish kind of point, isn't it? It's on the line y equals x. So that's an angle I know is 45 degrees. And now I've got an eighth of a circle minus a triangle. Okay, so I've got some sort of circle minus triangle calculation to do. And circle minus triangle calculation is going to turn out to be something involving pi minus something involving surds. It's going to be b, I think, in the end. Yeah, so which bit are we looking for? So this is actually a really good question. First, let's have a quick look at chat and see how chat found this question. Chat, how did you do? Ooh, chat voted for C a little bit more than B. People really liked that 2 root 2 over here. What's that come from? Okay, that's interesting. So, maybe that's... Is that the area of the semicircle? What's going on, chat? Help me out here. People are now changing their votes or voting for the right answer, I don't know. What's pi over 2 root 2? Where does that come from? We've got up to 51%. Okay, let's have that. We are doing a little bit more coordinate geometry than Euclidean geometry here. Okay, I want to work this out. I'm doing algebra. I did do the algebra. I didn't regret it. It was good. Okay, people are now catching up with people telling me to do the algebra. Yeah, so there's a decision about looking for easy points or just going into algebra mode. Depends how happy you are with algebra mode. I was pretty reluctant to do the algebra because of squaring loads of root 2s. I thought I would probably get it wrong. I was much happier about guessing points. Up to you, I suppose. Admissions questions. Somebody's asked, can we just look at the forms the answers are written in and then just guess? Because it's probably sector minus triangle. Sure, yeah, if you want to. You're allowed to guess on the short questions. You get all the marks if you get the right answer. Here, the guessing is looking a bit 50-50, isn't it? People have gone 50-50 between pi over 2 root 2. People didn't really like this. People like the format. The question's just really tricky. I still want to know how people have got to pi over 2 root 2. Because I'd like to understand people who picked C, but they haven't told me how to pick C. I don't quite understand how the first equation is a quadratic with roots of root 2. It looks like the formula for a circle rearranged to me. Yeah, it is a circle. I've been saying quadratic out loud, but it is a circle. Sorry, yeah, that it really is a semicircle. Root 2 and minus root 2. Those are it's a circle of radius root 2. So those are the points where, yeah, okay. Ben says, change my mind, I don't like geometry. Okay, I think no one's going to explain to me why they picked pi over 2 root 2, which is fair enough, but even anonymously, but never mind. What is this pi? So it's root 2. I'm going to try and work out what you've done. So pi is root 2. You find the area of the semicircle? Maybe it's just not obvious that we're looking for this bit of area. We're looking for kind of this bit of area. When we say bounded by the graphs, we mean a kind of finite bit of area with finite size that's all of the edge is made of graphs of these two. Yeah. How did I get y equals 0 or y equals 1 out of this equation? I did the last bit of rearranging in my head, which is a bit rude, isn't it? I cancelled the 2's, and then I worked out that I was going to get this bracket here was going to be root 2 is 2. There's going to be something like 4 minus root 2. Maybe I'm just wrong, who knows? I did some cancelling in my head and I might not have done it all correctly. Ah, yeah, there's a big minus sign. It's all fine. It's all fine. So over here, I'm going to get 4 minus 2 root 2 y squared on the left when I add this on because of this minus sign around this bit of y squared term. And on the right, I'm going to get minus 4 minus 2 root 2 y. So I sort of saw that coming, and then that's either y equals 0 or 4 minus 2 root 2 cancels out, y equals 0. Okay. Yeah, how do I know that angle is 45 degrees? It's the angle between the x-axis and a line that goes up through the point 1, 1. So I suppose I know that's 45 degrees because I'm imagining this kind of nice picture of a square. So 1, 1 square, and then this is the diagonal of the square. Squares have right angles and they have the same side length. So this is 45 degrees. But I suppose really it's because I've thought about the line y equals x before, and I just know that the line y equals x is at 45 degrees to the line y equals 0. That's just come up for me before in my life, so I could just write down 45 degrees without thinking too hard. I'm going to put a kind of blob around that. It's something I'm thinking. That's not clear at all, is it? Okay, cool. Let's turn this off and not talk about that one again. People like coordinate geometry, or one person in chat likes coordinate geometry. Would have preferred inequalities. It's got another root 2's. Is it 4 plus root 2? No. 4 minus root 2. 4 minus root 2. I'm going to 4 minus root 2. Yeah, cool. Do we need to memorise exact trig values? Somebody's asked. You should know a few. You should know the 45 degree ones and the 30, 60, 90 triangle. And you should be able to work out other ones. We talked about trig values last week as well. We had the 45 degree ones and the 30, 60, 90 triangle and other ones. Pi squared over 6 was my... I put hashtag Euler because that's turns up in a famous bit of maths by Euler. I don't think anyone could possibly pick it for this circle question, really, but hey. Key idea that somebody spotted earlier, the key idea was turning things into a kind of geometry picture. Draw a picture, have something about a semicircle and some triangles going on, because we know a formula for the area of a circle. So that rather than doing some complicated integration or thinking about areas in some complicated sense, we just know how big circles are. I guess it's important to have that kind of awareness that you know a way of finding areas by integration that's really tricky, and you have to do loads of work. You also know just a fact about how big circles are, and if you can use that fact, then it's much better. Ah, right, that was not fun then. Okay, people did not like that one. I have a 3 that's meant to be a 4. Okay, I've maybe got some numbers wrong. Other people are telling me they've got numbers right. People did choose Euler in the end for the poll. Right, good. Oh, maybe it's divided by... Okay, maybe someone's put a suggestion that it's out by some factors of root 2 for the area of a circle. If that's what you did, then that makes sense to me. That's not stupid. Right, cool. People hate coordinate geometry. Cool. Brilliant. Okay. Good. How will we do that in 5 minutes? 5 minutes? So doing that in 5 minutes would be, I guess, a bit of a rush to get things done in time. But you know, we could have a go. I'm going to skip this one. I don't love this question. I'm not sure it's very important. It's to do with having a line that goes around a disc, and in this question they tell us it's a disc, so it's reminding us that's a circle, kind of circle disc shaped thing. I don't love this question. I'm going to skip it. It's on screen if you would like to look at it. There you go. Pause this video if you'd like to try this question, or look it up in MAT 2017. Solution's going to be out tomorrow. I would like to talk about this question, which is 2016 question I. Yeah, so we could divide by cos theta as a good start, if cos theta is not 0. People are now very much in the 1-star camp. I wonder if we're making the distribution more bimodal. I don't want to do that question. Right, cool. I really like this one though. So this is about maximising a thing. We're given a circle, x squared plus y squared less than or equal to 1. That's some region of space. Here the question doesn't say circle, but hopefully everyone in the geometry session is thinking circle. Oh, that's a pretty good circle. Okay, we've got this circle. I've drawn a tiny circle. I'm going to regret that. Reverse, reverse. Oh wait, no, go back. X squared plus y squared less than or equal to 1. and then we're asked for the largest value that ax plus by can be. So largest value that could be. So I guess the way into this question is to think about what happens when ax plus by is a particular value. When does it do that? When does it take particular values? I've got a poll for this one. Let's do a poll. Let's do a poll with the numbers on. Okay. So this is a bit multiple choice. So you can attack this with multiple choice. It's in terms of a and b, which are positive numbers. So you can attack this a little bit by choosing your favourite values of a and b and then trying out the question. So if you set a and b to both be 1, then then the question just says, what's the largest value of ax plus by? That means x plus y, if a and b are both 1. We're looking for an answer in terms of a and b. That's going to be true for particular values of a and b. So here people are saying, aha, I can make ax plus by, I can make that really big. Well, if I plug in the point 1, 0, that's pretty good because that gives me a, that's the value over here, when x is 0, when x is 1 and y is 0, this is the value a. Or I could plug in up here at 0, 1, I could plug in 0, 1 and get b, that's the value over here. And then if I'm greedy and I want the largest value, then I could take the maximum. So I could choose one of those two. It's a good idea. Choosing one of those two gives me a bigger value. The question is, can I make it bigger than that? Can I get larger? Suggestion in chat that ax plus by is constant. It takes the value c for some constant on a line. So maybe if a and b are both 1, then that would be something like this line. If a and b are both 1, then it takes the value 1 at both of these points. But we can make that constant a bit bigger. Yeah, at 45 degrees, we can make this a little bit bigger. So this line takes a bigger value, or sorry, ax plus by has a bigger value when the constant c is, if we make the constant c bigger, then we get bigger value. What does that actually look like in terms of the line? Well, the line would go, if I increase c, then that's like making the values of x and y bigger. So if I increase c, maybe I've got bigger c and I've got a line over here. If I make c too big, then I've got the line x plus by equals c. I've got a line over here, and there are no points inside the circle that do that. So that's no good. I got too greedy. I made c too big. I got this line over here somewhere, so that I couldn't have that inside. And someone anonymous has put the word tangent in chat, which is what I was looking for, because just the kind of perfect compromise between, I want to make c big, I want to get that line far away from the origin, I want to make c huge, big values of x and y, I want to make c really big, but I need to have a point inside this circle. I could choose a point that's just tangent. Great idea. So you can actually work out, with all of that information, you've now got a line, you know the gradient of the line because you know its formula, ax plus by equals c, you know the equation for the line, you know where the circle is, you're looking for a point of tangency. You can do that like a geometry problem, writing down, radiuses and square and right angles and doing all your geometry stuff, using right angle facts like that. But you can also do it like a algebra question. If that's tangent to the circle, then it means there's a repeated root between the two equations. So you could write down both of these equations, one for the circle, one for the line, look for a repeated root. Either way, you get to the answer that 100% of chat have put, which is option C for square root of a squared plus b squared. Good. Is C the only one that can be irrational? Well, it depends what A and B are. I don't really understand. Sure, cool. So it's about maximising the thing. Make this expression ax plus by really big. I can make it really big by choosing the value c, so that this is a line that's really far away from the origin. Maybe it's helpful if I say this line has y-intercept C over B, and it has x-intercept C over A. So C, the thing that I'm trying to make really big, is everything to do with how far away this line is from the origin. Yeah, somebody's asking, what does max A be? Are we expected to know or use this? I'm not really sure. It's not the right answer to this question. Max AB means the maximum of A and B. I'm not really sure about that. I think if that came up in a question, I think normally we would have to explain what that function means. So here, maximum of A and B means that if A is bigger than B, we take the value A. If A is less than B, then this takes the value B. But I think, yeah, if we had a maximum function in a question, then we'd need to define what it did in terms of the input variables. Okay, a little bit tricky. It's a function of two variables. You don't see a lot of these, do you? Function with two input variables and gives an output variable. Okay. How can a tangent be the maximum equation? Only touch the circle once. You can have points A and B. I suppose the numbers A and B are both working together to tell me where this point is, and then at this point the value of ax plus by is just one number. So it's okay that I'm taking two numbers, they're kind of competing, I'm using both of them to work out where this point is in terms of A and B. It works out that if A is really big, much bigger than B, if A is huge and B is really small, then you want to get greedy. You want to look at a point that's quite near x is 1. You want to make the most of having large value of A. Oh, huge number of A. I'll take 1 over here and 0 over here, almost. If B is much bigger than A, you want to do the opposite. You want to say, well, B is much bigger than A, then I want to be near y equals 1. You actually have it's not quite 1, 0 and 0, 1. How does the repeated root algebra thing work? It's a good question. So finding a point of tangency. So tangent would be if x squared plus y squared equals 1 and ax plus by equals c has a repeated root. So sometimes that's got two solutions, sometimes it's got no solutions, sometimes it's got one repeated root, which you can work out by plugging one of these into the other, and what am I doing? C minus ax over b all squared. Oh, goodness me, what a mess. Rearranging that quadratic and saying, I want this quadratic to have not two solutions, not 0 solutions, I want it to have one solution for where this point is. That's what I meant by the repeated root thing. Cool. And this is actually quite a nice inequality, but never mind. Right, cool. I'm going to point at the long question. We're not going to talk about the long question in much detail. I quite like the long question. Here's the long question. Turn that off. 100% success rate. Wow, amazing. Thanks for joining in with my multiple choice poll. Let's talk about the long question, and then people are asking admission stuff as well, so we'll get onto that at some point too. The long question is about 3 circles that are all tangent to each other and tangent to both of these lines. I've got 0% chance of drawing this, by the way. So it's got this circle C1, which is over here, and then it's got a circle C2, which is tangent to both circles, tangent to the previous circle and to both lines. And then there's a circle C3, which is tangent to that circle and also tangent to both lines. That's not good enough. The last 3 minutes of this live stream is just me drawing circles. There we go. Okay. And we're asked lots of questions about the relationship between the radiuses of these circles. I think we're told first that this one's got radius 1, and then we're asked about the radiuses of the other ones. Or maybe we're told this one's got radius 3 as well. And then it turns out that this one has got radius 9, which you work out by doing some sort of similar triangle stuff. There's some real sort of similar triangle stuff going on in here. If you don't like similar triangles, then you can do everything by drawing just a couple of different triangles and using trigonometry on them. Yeah, halfway through we work out how big this angle is, this kind of mystery angle down here. But we know so much about where everything is that doing this with coordinate geometry, of just writing down where everything is a really good way to attack the problem. I quite like it because it kind of magically turns out halfway through that 139, the sort of geometric sequence again, as a geometric sequence turning up in a question that's got nothing to do with sequences, except wait a minute, geometric sequences, they're called geometric sequences for a reason. That reason is geometry. So maybe it's not a surprise that the geometry problem has a geometric sequence hiding in it. Good, yeah, there's a really nice line. I'm going to try and draw this line. Okay, whoever you're, anonymous person, you've got a thumbs up, and I'm going to try and draw the line that you suggested. Goodness me. All the centres are on alpha from the x-axis. So this is a really good suggestion. They've marked 2 alpha in the question, but a really good suggestion is to draw this line. Not quite today. Okay, there we go. Which perfectly goes through all of the centres. And then that's angle alpha. And it sort of perfectly bisects. There's a nice line of symmetry, isn't there, between centres of triangles. I think that's one of those facts you learn at GCSE or equivalent, where you learn that these angles are both alpha. Anyway, that angle's alpha, and now I've got loads of right-angled triangles to play with. My favourite. Yeah, cool. So I can do loads of sort of trigonometry and coordinate stuff. George wants to use similar trapeziums. Fine, okay. There are some trapeziums in here, aren't there? Very nice. How do we know that C1 and C2 touch? I think we're told to work out the value of alpha such that C1 and C2 touch, which is something that happens during this question. So I've drawn them touching. Earlier on, I think we're not told that. Earlier on, they're just 2 circles. But then as soon as C2 comes into the question, we're told that it touches C1. So I've drawn it touching C1, as if it always was. This is not the sequences live stream. We already had the sequences live stream. That's happened. So kind of progress through the question is something like, draw this picture at some point. I guess you can't draw all of the picture straight away because we don't actually know this is 9 yet. I learnt that during the question, but hey, maybe draw a couple of circles in. First, they just want to talk about C1. So this is just the first circle. So just looking at this bit of the picture, thinking about trigonometry, where is the circle, right? We're asked the centre and the equation. That means we need the x-coordinate of the centre, the y-coordinate of the centre, and the radius. We already know the radius is 1, so the only question left, I suppose, is where's the circle? Which sounds like a coordinate geometry question, if I ever heard one. And then in part 3, the circle C2 is introduced as well. So now we're thinking about this pair of circles, and thinking about the fact that this radius is also 1, this radius is 3, and because there's a point of tangency here, the circles, that's a straight line. Maybe that's obvious from the brilliant line that an anonymous person got me to draw. It is a straight line between those centres through the point of tangency, with radiuses 1 and 3 there. That's pretty good observation. That I don't think I would have that observation unless I drew the picture. Got to draw the picture to have that idea. That lets us work out the angle alpha, because now we've got loads of information about what's going on with these circles. Work out the value of alpha using some trigonometry, and then project that up to work out the size of the big circle. We'd like to know the radius of circle C3. Turns out to be a geometric series, loads of similar triangles, or drawing the same diagram twice going on there. Final part of the question to work out this bit of area in here, which is, I think, semi-obviously, but not very obviously, is trapezium minus some bits of circle. Cool. I do actually want to know. I'm going to clear this poll and run it again. I won't be offended if you vote 1 star, having voted not 1 star before, but I would kind of want to know. Can we use 2 alpha in the diameter of the circles? So the diameter's tricky because it doesn't go... The top of the circle... The diameter doesn't go across to the other point of tangency. There's a good suggestion from Emily. Think about the diameter. But actually the top of the circle, you can't tell from my very lumpy drawings, but the top of the circle is not quite the point of tangency. The points of tangency actually, it's over here somewhere, it forms this kind of kite with some right angle corners, and then this thing is not quite a straight line. I guess draw a picture where this is a 45-degree angle to convince yourself that this tangent unfortunately doesn't hit the top of the circle. Yes, good. Do you want to do the last warm-up question or wait for the solutions? I don't mind going back. Oh, look at this distribution, by the way. We have, right, okay, so two things have happened. The average has gone down. The average is now 3.1. That's great news for my value as a teacher, right? Started at 3.6, 3.7, down to 3.1. The number of 1-star as a percentage, the number of 1 stars has gone down a bit, which I'm happy with. Also the number of like 5 and 4 stars. I guess the number of 2 stars is pretty high. I'm going to hope that's 1 up to 2. I think I've brought a few 4 stars down to 3 stars. And we're bimodal again. Look at that. Lovely, almost symmetric bimodal distribution. Very nice. Oh, there we go. 3-way tie, just what I wanted to see. Lovely. Here are some good questions that are coming in. So one person wanted to talk about a warm-up question, and it's actually a warm-up question that I enjoyed writing, so I'm going to look at it very quickly. Going sideways across the page to look at this warm-up question with the bizarre hint angles. I'm quite proud of this question, so I'm going to talk about it a little bit. You're given 3 points. The origin, the point 1A, and then this bizarre point, which is somewhere up here. 0 and then A plus a bit. And you're told that there's a circle that goes through all of those points. Is there a circle tool? There's a circle tool. Oh, imagine how much better the live stream would have been if I'd found this earlier. Look at that. It's better than any circle I could ever draw. And it'll let me type in it. Oh, amazing. Okay. We've got a circle. So the question's a bit mean because in general this is very, very hard to work out given 3 points. I mean, it's not impossible. It's something that people can work out, but it's pretty tough. The hint is angles, to think about the angles between some of these points. If I join them up, your hint was angles, to think about the angle between some of these lines. So most of the angles I can't work out in a sensible way. I mean, there's something to do with A and arctans and tangents and going on with A, but there is an angle that I can work out, that's not too bad. It's this angle over here. Because the gradient of this line has gradient A, because it goes from 0, 0 to 1A. This line has gradient, well, it goes from 1 down, the x's change from 1 to 0, and the y's change from A to A plus 1 over A. So it has gradient minus 1 over A. Going left to right, it decreases by 1 over A as you go from 0 to 1. So it has gradient, am I spelling gradient right? Who knows? Gradient minus 1 over A. Aha! These things multiply to minus 1, so these are at right angles. I'll say that again in slow motion. So these things, the gradients multiply to minus 1. If the gradients multiply to minus 1, it means that these things are at right angles. That means that this is 90 degrees, and now you're way ahead of me. You've worked out that if this is 90 degrees, then this is a semicircle. Or this is the diameter. If this is the diameter of the circle, then I can find the centre of the circle by looking at the middle of the diameter. It's somewhere in the middle of the diameter. So it's sort of a mean question because, I'm allowed to say that I wrote it. It's sort of a mean question because this calculation is really difficult in general. I really wanted you to think about gradients of lines and to notice that 2 of the lines were at right angles to each other. I wouldn't do that on a maths question, probably. Don't at me if I do that on a math question. They are perpendicular. People in chat were on there. How would you find the area of bits of the circle? Yeah, the bits of the circle. I think I've only got that recipe from the start. That's my way of working it out. Cool. Okay. Yes, people in chat are suggesting all the right things. Thank you, Mo. Thank you, George. Thank you, Rilo. Mo says, I got it right yesterday. What do you know? Let's go. Yes, circle theorems. It's a circle theorem question. Love a good circle theorem. Right, cool. Okay, we're going to turn this off. 3.1 in the end. We tried. Let's take some questions. Am I the only person? Okay, so am I the only person who found everything hard, even though I did one in April? No, I think everyone found everything hard today. I After sequences and trigonometry, which I think people are quite happy with, today seems like a hard live stream. If we'd done more of the long question's not too bad, but we did the short questions, and they seemed more tricky. So I've thrown some harder questions at you today. Don't feel bad if you found this hard. It's sort of supposed to be hard. We can't see chat. No, you can't. I've put chat back. It is still in poll mode. I've got to work out how to do that. I've got to work out how to have both. The worksheets beforehand are posted on the homepage, maths.ox.ac.uk/r/matlive. You can also get previous recordings of other episodes. Those are also on this YouTube channel. And you can do things like get the solutions, or read other stuff about maths, or watch my entire personal statement. Right, cool. People are not fans. Right, people want to ask about admissions. So the R means redirect. It's also the notation that Reddit uses for the different Reddit boards on Reddit. So sometimes people think that it's a Reddit thing. It's not a Reddit thing. /r/matlive, that could be a Reddit, but it's not a Reddit. It's how our website works. It's got the main bit of the website and then redirect to MATLive. Second multiple choice question. I've got a suggestion from Max Verstappen, extending our F1 theming. And SV's helpfully put a link to today's worksheet. If you go there, you can find the other ones. Not a subreddit. Cool. And now obviously everybody wants to make a subreddit. Okay. Oxford's not responsible for the content on third-party websites, especially Reddit. Oh, how did I know that was alpha? Yeah, this is a good question. How do I actually know that's alpha? And it's because of similar triangles. Am I going to get away with this? Not sure if I'm going to get away with this. No, I'm probably not. There's a circle theorem that says that the tangents, the lines of... There's a circle theorem that says the distances made by tangents through a point are equal. So here I've got my two tangents to circle C1. Those are equal. And then I've got similar triangles because the radii are equal, and these are right angles. I've got similar triangles, so these things have the same angle down here. I think that's equivalent to me just saying, there's a circle theorem that says it, but I've got some kind of idea about symmetry in mind, and it's backed up by one particular circle theorem. At MAT, I would just accept by symmetry, reflection in the line. Seems quite nice that it should be alpha on both sides. Okay, time for questions in chat, I think. How many marks is the whole test worth? Somebody asks. It's 100 marks. There are 40 marks available for multiple choice questions at the start, and then 60 marks for longer questions. So 100. Symmetry of a kite. Yes, thank you, Riley. Is it important to read books for mathematics? I think not as important as for other subjects like English or history, or reading other people's opinions about politics or something like that. In mathematics, I think one of the nicest things about mathematics is that you can practice mathematics just by discovering it, or just by drawing diagrams and writing down equations and practicing like that. So in some sense, one of the things I like about mathematics is that you don't need to read somebody else's opinions in a book or somebody else's stuff. You can get inspiration like that, but you can also practice exploring the things that you know. You can work out consequences of the things that you know yourself without other people telling you them. In the kind of debate, is maths discovered or invented? You can discover it. So I think I'm on the discovered side. Okay. Not the question at all. Look how different the question is to what I said. Okay, cool. I did ignore Max's question. Sorry, Max. Do you want to ask? I've starred some of them as I've been going along, but I've been trying not to talk about A-levels or things like that while I'm going. They are congruent. It is the angle bisector. Goodness me. Here we go, chat. How many tips to get high scores on maths? Okay. Right, I'm storing up questions that I've been not answering over chat. If you don't want to hear me talk about admissions, which I sometimes do, then I'm about to start talking about admissions. Sorry. B's asked about personal statements, which I can do. Favourite fun maths book? I really like anything by Ian Stewart. Ian Stewart's got books like Math Hysteria and stuff like that. Radius is 9 is part of the question. So this 9 is part of the question to work it out. I put it on the screen because it's cool and fun, but it's actually part of this question to draw some triangles and do some trigonometry. It's not straightforward. It's not like obviously 9, maybe. Okay. There are part marks for the long questions. Oxford doesn't tell you how many marks the long questions are worth. So here it doesn't say how many marks each part of the question is worth. The reason we do that is that we don't want to tell you which bit's difficult and which bit's easy. We don't want to give away that something might be easy or have a nice, simple answer. We might want you to think about it a bit without just guessing easy things, so that you can have that idea and then get the marks. I think it's usually when you start doing the question, if you're doing lots of work, you're probably going to get lots of marks. That's usually how the mark breakdown works. It's not really a very complicated process for deciding how many marks each part's worth. The bits where you do more stuff are worth more marks. I could try and guess how many marks these are worth. We could look it up on the solutions document. I reckon that centre's worth a couple of marks, maybe 2 or 3, and then the equation for the circle C1, I'll give you 1 or 2 marks for that, I reckon, because you just write it down. Finding that value of alpha is quite tricky, so maybe 3 or 4 marks, and then value of alpha where the circles touch, you're probably going to get 3 or 4 marks for doing that calculation as well. And then that area calculation is a little bit tricky. You've got to do a couple of steps, so maybe 3 or 4 marks there as well. Adds up to 15. Question about PAT. Do they do the same sort of thing with infinitely many circles in UKMT? I can imagine that. Yay, B's already read a book by Ian Stewart. Love Ian Stewart, great author, very nice. What's a good score, says Bert. About 70 to 75 is a good score. Rilo would like to know, this is team effort now, Rilo would like to know a problem that B mentioned last week working on something involving tetrahedrons or something got mentioned? Anyway, do we have a lot of paper? The test is in a 32-page booklet, so you get 32 pages. You answer in the booklet that the questions are printed on. You don't answer on rough paper, loose paper. You answer in the booklet. There's some space. If you look at the 2020 past paper on the website, so you find the MAT Live website, you get to the MAT website, and you find the 2020 past paper. That's laid out in the same way that your test booklet will be laid out. Good. If you do really well, can you skip the interview? As a genuine question that's just come in from an anonymous person. No. If you do really well, you still have to do the interview. Right, okay, I've got 15 questions I've starred. The long questions are guaranteed to be worth 15 marks, Todd. Definitely worth 15. Right, cool. Okay, let's go all the way back. So someone about an hour ago said they completed their A-levels 2021. They're wondering if that's a problem. It's not a problem. We're going to treat grades that you get in 2021 or grades that you got in 2020, because people were worried about that year as well. Grades that you got in those years, just like normal. If you got A star, it's an A star. If you got A, it's an A. We're not going to try and undo grade inflation or anything crazy like that. It just means that more people than normal have got A stars, but you did a lot of work under strange circumstances. Cool, we're going to count it as an A star. We've still got things like the maths, right? So even if everybody gets A star, Oxford's admissions for maths still sort of works. That okay, everyone's got A star in maths. Great, here's a maths test. Let's find out. So in some sense, it doesn't matter too much to Oxford if everybody gets A star in maths and per maths. Ellie's degree rating question we did. Why did the math post not have marks? There's a question we got a thumbs up earlier about predicted grades. If predicted grades don't meet the offer, but our math score's good, so that's the order that things happen in. You get predicted grades, and then you take the maths, and then we decide if we're going to invite you to interview. And we could. If you've got a good math score, then we can invite you to interview. It would be tricky. We'd probably need to have a reason to think that you were going to beat the predicted grades. We know that predicted grades are not always perfect. We're much more interested in actual tests that you've done, like the maths test. So we could shortlist you for interview. So, somebody asked that a good sort of hour ago. Good. Pat question. What's the Pat question? The interview is the fun part. Thank you, Rilo. Interviews for maths. We're just going to ask more maths questions. We're going to do maths questions with you like this, but instead of having however many people here, just we're doing it at your speed with you answering the questions. It can be fun. You don't have to have somebody else talking loudly about their way of doing the question. You don't have to. You have to deal with everyone else doing their parts of the questions. Cool. Right. Okay. What was the PAT question? So the PAT question was, I'm preparing for the PAT exam for Oxford Engineering, but I'm really struggling to find resources to prepare for this. So the physics website does have some resources on. They've got some suggestions of how to get better at physics, and they've got a very limited syllabus as well of physics that they're expecting you to know, and some maths that they're expecting you to know. Is there anything like the MAT Livestream? So there's a preparing for the PAT video that's been made by the physics department with Catherine Boast. I think that's on the physics website in the undergraduate applications section, and I think it's on ox.ac.uk ox.ac.uk/PAT, I think has got that video as well. Just a short video explaining how you can prepare and naming some other resources as well. So other stuff. I don't think they're doing. They're doing something like this. They're doing there's some sort of live problem solving thing going on as well. So maybe have a look for physics events as well. Good. Okay. Then there was a question. Should we do this one now? This is kind of a live question by someone who's definitely right here. Lots of paper. Right. Okay. Personal statement question. Let's do the personal statement question. Personal statement question was, I have 2 books left that I'd like to read. Don't believe I have the time to read both. Is it okay to finish one and fully understand it, or somewhat understand both? I'd go for one, I think. I like understanding things. You know, that sounds like a good skill to have. Understanding stuff and thinking about it a bit yourself. I think that's more important than breadth of reading. I don't know. It's kind of how I feel about reading in books, I suppose. What else are we doing? Are the interview questions harder than maths? I suppose the interview questions are a bit harder than math questions. We can make them harder. We can go further. If you can do part of the question, we can ask you a bit more question. We can keep going. We can do it like that, so that we sort of build up the question. So we can make it harder than a math question. But we're there to help. The interviewers are there to help and give you hints and break down the question for you, help work out how to make progress with things. A while ago, someone with the username Simon Singh asked, on the longer questions, are partial marks awarded within each part? Yes. So you might get some marks for working out, and then some marks for getting the right answer separately. It's not all or nothing like the short questions. Questions just come in about international A levels. International A levels we treat exactly the same as normal A levels, so that's fine. Personal statement statistics. Somebody has very hastily made a Discord, so I need to say that Oxford's not responsible for the content on external Discord sites. And actually, people have made multiple Discords, so good luck with that. So people don't. There's a question that's just come in as well. How would somebody fail on the interview? And people don't really fail the interview. People do great maths. People do maths with us. We ask them maths questions. They answer the maths questions. We're lucky that our applicants are actually pretty good at maths. So people don't fail the interview. We just think about how much progress we made with the maths questions with different people, how they responded to the maths questions. It's not the case that we've got some people who pass and some people who fail. We've got everyone passes and does well, and it's taking the people who are doing the best with the most potential to succeed on our course. I guess something I always want to say there are hundreds and hundreds of people who apply each year who don't get to end up studying at Oxford, mostly because we don't have space. And I really hope that they don't take it too personally. I really hope that they study elsewhere and do excellent stuff in maths degrees. I don't really get to say this to people, but you haven't really failed. You've done brilliant things. You've done loads of maths. And people should be proud of their progress through applying to Oxford and the things that they learn along the way of applying to Oxford, even if they don't end up studying at Oxford. I don't really get to say that to people, so cool. How long should we spend writing our personal statements? I don't have a standard answer for this one. So you can spend as long as you like writing your personal statement, I guess. I'd encourage you, after you've written a couple of drafts of your personal statement, maybe you've written 1 or 2 drafts or 3 drafts, is that what people do? Once you've written a few drafts, doing maths instead is probably a good idea, rather than endlessly rewriting your personal statement. But I guess it's different for different people, probably. Matt does have, okay, somebody a while ago, I've lost the question, but somebody a while ago asked what a normal number of interviews is. For maths applicants, I guess a normal number would be about 3 these days, about 3. Varies a little bit depending on how colleges want to do them, but normal kind of experience would be 2 interviews with a first college, and then we assign you a second college, maybe 1 interview with your second college as well, so a total of 3, but varies quite a bit in practice of how many interviews people actually do. How many interviewers? 2 interviewers, or sometimes 1 interviewer and 1 person who's taking notes and keeping track of what's going on, but two of us, at least 2 of us, maybe 3 of us, but usually 2 of us, 1 of you. Can you describe a little of what Oxford looks like, what Oxford looks for in young mathematicians? And I suppose here we're looking for people who are interested in mathematics, who are excited to study 3 or 4 years of mathematics with us, and are pretty good at solving maths problems and doing mathematics. Really, that last part is the most important part. People who are just really excited, I guess, about having 3 or 4 years of being shown lots of mathematics, learning lots of mathematics, and doing lots of mathematics as well. Right. B is doing it. Oh, B's actually linked to the problem. Thank you, B. Something about bullets. So, goodness knows. I don't know what is that PG-13 or I don't know. Okay. Your suggestions. There's not a question at the top here. Your suggestions on how to write the personal statement. Give the suggestions point-wise. Okay, so first point, be personal. Talk about yourself. Second point, tell us about why you're preparing for university, what you're doing well, how you're preparing to do well on a maths course. Third point, talk about mathematics that you're interested in, what you've been thinking about in preparation for university, what sort of stuff you're perhaps interested in. In general, I think that helps make you look like you're interested in doing mathematics as well as good at doing mathematics. You talk about that as well. That could be my 4th point. I think that was point-wise. Is that 4 points? Okay, good. Right, okay, how are we doing? What are we doing? Who are we? What are we doing? So very particular cases. I'm going to take this question, I think. Why do we need more than 1 interview? So we like to do more than 1 interview so that we give you more chances to do more bits of maths with different people. Sometimes people are very nervous in their first interview, and then we find that after their first interview, like their second or third interview, they've worked out how this works and what sort of stuff we're going to do, and they do perhaps better maths in their second and third interviews. So we found that having more interviews gives people more of a chance to demonstrate stuff like that. Some other universities don't do that many interviews, but we think it's really important to use lots of resources on giving people lots of chances to do mathematics. I'm going to turn a light on. Right, some sort of professional live streamer will probably have a button on some sort of stream deck to do that, live from here. Okay, what else are we doing? What are we talking about? Is it okay if I don't mention books on my personal statements? At the moment I've mentioned some lectures. Oh, okay. Yeah, it's fine if you don't mention any books. There's no rules about mentioning books on personal statements. Do we reimburse travel expenses? I think there are some schemes to reimburse. Wait, no, hang on. We're doing all of our interviews online this year. No, not this year. We're doing all of our interviews online. So, no, easy answer. No one's coming to Oxford. Normally we have some travel bursary schemes for some UK students who need the support to travel to interviews. We don't have a blanket policy of paying everyone's travel expenses to get to interviews. Okay. Somebody wants me to talk about computer science, which I'm less good at, so that's why I'm talking about maths quite a lot. I'm talking about maths quite a lot because I'm a maths person and I work for the maths department and the stats department. Computer science applicants also need to be good at mathematics, so that helps too. What's this computer science question that's coming up on screen now? I was applying for maths and computer science. What's a good maths score for applicants? You can find stats for maths and computer science on the computer science website. They do stats for maths scores of previous applicants on there. There are lots of applicants. This is not true. There aren't a lot of applicants. There are a lot of applicants for maths and computer science. Somebody asked who usually does the computer science interviews, so they can try and find out areas of interest. You really do not need to find out areas of interests of professors. It's actually unlikely that they want to ask questions about their area of interest. They're probably going to come up with clever things to ask you about that are related to maths on A-level, which might be nothing to do with their interests. I think I have to say this because my interest is fluid dynamics. I do not ask interview questions about fluid dynamics. I'm capable of coming up with other interview questions that aren't about my research. Do I think next year's open days are going to be in person? Yes, I think the 2022 interviews are going to be in person. I'm optimistic about that. I think 2022 we're going to be able to do some interviews in person. You can come and see us in actual Oxford, in actual humans. Right. Oh, here's a question that I quite like. I really like statistics, but I found not many people actually like it. Things like analysing data and distributions and finding out about the objects of study. Really fun. There you go. That sounds nice. I'm glad you found a bit of maths that you really like. I hope everyone finds bits of mathematics that they like. Yeah, and don't take it. So yeah, it sounds like you've met people who don't like statistics. Don't listen to them. We all know people who don't like mathematics. We've learnt not to listen to them. If you're meeting people who don't like your bit of mathematics, don't listen to them. It's the same thing on a smaller scale, like similar triangles, right? You have those people telling you, "Oh, I don't understand maths," and then people telling you, "Oh, I don't understand statistics." Don't worry about it. Cool. Managed to get similar triangles into an argument about not listening to maths bullies, but I used similar triangles to explain it. Right. Okay. Maybe there's a reason. Right. Do I like programming or computer science? I like solving things with computers. I like doing things with computers when I can. B says, do you only apply to one college? Yes, you only apply to one college. You can actually apply to no colleges. If you make an open application, you apply to 0 colleges, but then straight away you get assigned to a college, and then you get treated exactly as if you applied to that college. So let's just say you apply to one college, and if you then get interviewed by a college you don't like, after that, so your first college is the first college that considers you, and then any other college in Oxford could potentially make you an offer. If your first college doesn't want to, or if they don't have any spaces left because they've given them to other people, maybe in other subjects, if they've given them to other people, then you get considered by every other college, starting with the second college that we assign you if you're invited to interview, but then any other college could make you an offer. Unfortunately, your decisions are, at that point, are pretty limited. Your decisions, if you get made an offer by a college, your decisions are, unfortunately, either take that offer and study with them, or do not come to Oxford. You don't get more preferences. Sorry. If it helps, all the colleges are great, and they all have access to exactly the same maths degrees, which is the thing we all care about, right? So, I would always advise people to take the offers that they get, even if it's not from the college they applied to. About 25% of our first years in maths aren't at the college they applied to, and almost all of them just really love the college that they're at. Books again. Ali's done the question on screen, which is something about, it's something like that, isn't it? Is it sine alpha there? Yeah, I think it might be sine alpha there, with big R and little r. Good, yeah, I think I agree. Either sine or tan, okay. Someone's 15. 2 years, is that a problem? There is no minimum age for applying for maths at Oxford. I think medicine has a minimum age for complicated medicine reasons, but there's no minimum age for mathematics. I'm going to scroll very slightly. Oh no, I'm not. Good. If you're trying to pick between maths and computer science, you could pick by, so for your personal statement, you could write about both. You could write about the intersection between those two things. Find the intersection between maths and computer science, calculate its area, and then tell me about it during your personal statement where you're talking about maths and computer science. I don't think it really matters, to be honest, for Oxford admissions at least, whether you're interested in purely the subject or the subject's applications or the subject and its applications. That's not really something we take into consideration when we're looking at your personal statement. if stuck on a multiple choice question, here, someone's got a sneaky idea in chat. Look at this sneaky idea. If you're stuck, could you just guess the answer and get 4 marks with no working out? Yes. You could do that. Ross wants to know what college I'm at. Ross, I am not at any of the colleges. I work for the department. It's part of my job to coordinate the process between all of the colleges to make sure that we're taking the best applicants between all of the colleges. So I don't actually have a college. I sometimes do some teaching for some colleges, and I sometimes do some interviews for some of the colleges. But right now I don't have any college at all. Can we visit Oxford at the moment, says Simon Singh. Simon is always welcome in Oxford. Oxford's the town, it's raining really hard right now, which is why I'm smiling. It's raining at the moment. Don't visit immediately now. Oxford, the city, is mostly open up at the moment. I think some of the colleges are letting people look around, but the maths department at the moment, the kind of building with the lecture rooms, is not open to visitors. I think lots of the university department buildings are not open. Some of the colleges are letting people in the kind of open air spaces, but at the moment the kind of is quite limited in what sort of tours you could do. You can look at some of the city though, from the streets, which is a nice city, even when it's chucking it down, like proper really heavy rain out there. Okay, is it okay if you have a clear preference for one part of mathematics, says Emily D? Yes, that sounds nice. I'm glad you've got a clear preference for one part of mathematics. You can tell us about why you're interested in it. Maybe tell us about why you're excited about studying it at university. If it's part of the degree course, if it's not, then never mind. But maybe you can tell us about how it's helping you with problem-solving skills. To have some bit of maths you're interested in. Fine. If I had to choose between College A and College B, which one would I choose? I can't help you, sorry. Which college is the most popular, / popular for mathematicians? I can't help you, sorry. Some of the colleges do have lots of applicants. I don't really know why that is. And you should at least look into like what are the colleges. Look at some of them online, I suppose, to try and find out what some of them are like. But yeah, I can't help you. Do interviews ever ask you things about personal statements? I personally don't, but I know some interviewers do. Mostly to sort of calm people down and ask them things that they're familiar with to get started. Not really. I don't think you should write your personal statement with the idea of that being a to-do list for an interview, because almost certainly the interviewer's got an idea for a question that they would like to do with you, something that you haven't seen, so that we can try some unseen maths problems rather than you setting the agenda. Sorry. What are some of the most popular colleges? When a personal statement's due, this maybe varies by your school or college, because they might want to help you with it or look at it. Who knows? Officially, you've got to put it on your UCAS application, and you've got to submit your UCAS application before the 15th of October deadline for Oxford. In fact, you're strongly advised to do it before that. Maybe like a week before that or something, because I think your school or college or your UCAS referee needs to press a button in between you pressing the finish button and the 15th of October deadline. So another step needs to happen. Please don't leave it to the last second. Please get your UCAS application done. Every year I watch them come in, and the most popular day, the day when we get the most of them, is the last day. It just goes up, and it's very scary. Okay. Please don't be one of the huge number of people who get their application to us. It doesn't actually matter, right? Get it in the last day, it's fine, right? We consider them all together. But it just terrifies me that there are so many coming in right near the deadline. But hey. Emily's got a book suggestion. Oh, it was the thing Emily's interested in, probably. Yeah, recommend it. Cool, thank you, Emily. Physics and maths, what do I think? Studying both much better, and I'll be doing physics, in my opinion. That's pretty much what I thought about at school. I thought I liked physics and maths. If I do maths, then I'll be learning how to do physics, and then one day I can do some physics. And then I never got around to doing the physics. Yeah, I think that makes sense to me. Don't tell physics I said that. Physics will tell you the opposite, right? Physics will tell you that physics lets you actually do the physics straight away, and they'll teach you all the maths you need to know along the way. Whereas the maths degree, evil maths degree, will tell you other interesting facts that aren't related to physics. Ooh. Yeah, you've got to ask them as well, right? That makes it fair. Okay. Which college is closest to the maths building? We're getting into questions I will answer. So Somerville and St Anne's are very, very close to the maths building. They've got some student accommodation there. So, you know, if you want the shortest walk. Okay. I think Christchurch might be the Gryffindor. Do we get a lot of international applicants? We do get a lot of international applicants. Yeah, quite a few. And we take about 180 maths students each year. About 180. It's quite a few. It's not a huge number though. We know numbers, we're maths people. 180. Quite a big number, but not a huge number. If you need more space, there's more space at the back of the booklet. In very extreme situations where you run out of space in the 32-page booklet, then what people have done before is start writing on random bits of paper, and then it's not quite what you're supposed to do, but people normally sort of staple them. Occasionally people have stapled extra bits of paper in, which you're not really supposed to do, but if it gets to us, we'll mark it. So our general rule is, if it arrives, we'll mark it. And when you get to the stage of stapling random bits of paper in, it might not get to us. But if it gets to us, we'll mark it. We're not going to destroy it. Cool. More interested in maths than rules in general, which causes problems sometimes. Okay. How can I motivate myself to read maths books? Because I find them so boring, but I love doing mathematics. It's a question in chat. I don't have a good answer for this, and I kind of want to unask the question. If you find it boring, don't do it. Do some maths instead. Sounds great. You've answered your own question. If you find it boring, just don't. That's fine. Lots of maths books are written by people for... Lots of them are written for a kind of general audience. You know way more maths than a general audience. What was the earliest we receive applications? I think we start getting applications in September at some point. Possibly before that, I'm not really sure. Definitely see some of them about 15th of September. We don't look at them. They just arrive. We don't look. We're waiting, mostly waiting for everyone to do the maths in November. So we don't... If you get your application in earlier, we're not going to look at it earlier and remember who you are. We're not even going to show them to the tutors yet. They just sit in a big pile of admin with nobody who makes decisions looking at them. Sorry. There's no reason to get it in before the deadline. Oh, except you should get it in before the deadline. Okay, you should get it in before the deadline. There's no reason to get it in before the deadline, except peace of mind and knowing you've made it before. Wow, I said that very wrong. Okay, graph theory. What do I know about graph theory? And Ali, I know you asked about something else earlier, but I couldn't think of anything for that one either. I don't know, sorry. Maybe other people in chat will have helpful book suggestions, but I don't know. Oh goodness, which college has the most international students? I've no idea, sorry. You do not get your MAT transcripts back, sorry. No. You're entitled to a copy of... Oh gosh, you're entitled to a copy of the marks that you're given and any comments that were written on it by the markers, but you can't have the script back, sorry. Somebody wants to talk about Navia Stokes. Who does the computer science interviews? A mix of computer scientists and some mathematicians, some graduate students involved as well, but yeah, computer science faculty at the different colleges do some computer science interviews. Please don't hassle them. Please don't ask them tricky questions. Most of them are just normal like researchers who want to get on with their research for all of the year except for the bit where they're doing interviews. Don't just because you suspect someone does interviews, don't bother them about interviews. Okay. Can you apply to different courses? What's this question? Different courses in the UCAS application, like maths for some and maths computer science for others. You can do that. That's allowed. Does it reduce your chances? I don't think so. We don't know who else you've applied to. So if you apply for maths at one university, maths computer science at another university, we don't know. We just get your maths application. That's called invisibility. Ooh, invisibility. Universities can't see your other applications. So yeah, there's no sort of prejudice there. Cool. Right, good. Does doing well at BMO and maths challenges have any correlation to getting admitted? I love it's a maths question now. It's not a policy question, it's a maths question. Or performance on the course. I don't know about correlation. It's a good question. I don't have a good data set because people tell us about BMO stuff. That's sort of, I'm taking that as shorthand for BMO or equivalent, right? Or equivalent for other stuff that people might do, like other competitions. I don't have a good data set for what people did, who did BMO and what they scored, and I don't really care because I've also got my maths test, right? And if you do well on BMO, then hopefully that's correlated with doing well on the maths as well, because they're both maths tests. But you know, I no one's done the correlation. Good. I like that you asked it like a maths question. You got a longer answer as a result. Do I know? I don't know Michael Goldsmith. I'm aware of the name, but I'm not sure that Professor Michael Goldsmith knows who I am. I think I know who Professor Michael Goldsmith is. Professor Michael Goldsmith is more famous than me. Right, cool. Senior maths challenge, you can't mention how you did. Yeah, I remember that being a thing actually. Because I did well on the senior maths challenge, and I was annoyed that I couldn't tell the universities I'd applied to. Doesn't matter. They're not going to take it into consideration really anyway. Probably. Somebody's just learned about Euler's formula. Hashtag pi squared over 6. Very good maths. Here's a nice... I like this. I'm going to highlight it as well. If you answer all of the interview maths questions well, is it fairly likely, even if you aren't particularly charismatic or even passionate, will you be accepted? And I think this is a reference back to something I said about being enthusiastic or excited about studying mathematics. Okay, so the second half of this question's crazy, but okay, the first half is even if you aren't particularly charismatic or even passionate, I want to say in like the strongest possible terms that is fine, even if you are not visibly interested in mathematics. We know that for some people on the autistic spectrum especially, being interested in mathematics is not obvious when those people are interested in mathematics. Why am I saying those people? I should include me. It's not obvious when we're interested in maths sometimes, because sometimes we're more drawn in. We know that's different for different people. Charisma and passion is all wrapped up in that a bit as well, I think. So it's a pretty dodgy thing to be doing admissions based on. And then the second half of your question is a good, charming personality valued more than maths ability? Definitely not, right? So I really want to stress that even if you're not charismatic or visibly interested in mathematics, if you're good at mathematics, that's much more interesting. Much better. Right. Somebody wants the CS department to do a live stream. CS department's a little bit smaller than the maths department, isn't it? They're doing a lot of interesting outreach. They do quite a lot of live streams during open days. So if you find out about the computer science open days or the big university open days, computer science do lots of live streams during those. So you can talk to them live during those. They're lovely people. If there are internet connection problems during an interview, very relevant with online interviews, do we organise another interview on a different day? We sometimes have done that. Last year we had, not that many actually, but we had a few technical problems, and sometimes we rearranged them. And because we've got multiple interviews with people anyway, in a lot of the cases we had other interviews with them anyway. So in some cases we'd already seen that they were great at mathematics and rescheduled the interview, but the first one had gone so well that anyway. And somebody earlier asked for a video about interviews. So we did a MAT live stream about a year ago on interview questions. It's quite long. It's about 2 hours long, and it's very rambly. It goes over lots of different bits and pieces very slowly. I've got another interviews MAT live stream thing coming up this year where I'm going to try and be better at doing it. So we're going to talk about interview questions. We're going to talk about interview questions after the MAT live stream. We'll keep going, have some interview questions in there as well. It's very similar in style to the kind of math skills that we're doing for MAT live stream stuff as well. So in some sense, you don't need that session, but people keep asking for it. So we're going to talk about interview questions. You can find a couple of them in things like Maths Club. A few of the problems that we talked about on the Maths Club were old interview questions, like when Tom Crawford came on and talked about rectangles. I think the episode's called Interview Question with Tom. It's in season 2, I don't know the episode number. That was an interview question. And there's also in there somewhere something to do with graph theory about connecting towns together that I used as an interview question. Oh gosh, which college is the closest to the computer science department except Keble? What an optimization question. I'm going to say possibly bits of St John's College are pretty close. Bits of I'm going to annoy a college here, aren't I, by forgetting about where it is. Little bits of Trinity College and Wadham College are very near the computer science department. Oxford's not a very big place, so all the colleges are quite near the computer science department. Cool. There were some other questions that I starred that I was going to look at. I can see that people are drifting off, obviously. Drifting away as well as drifting off like sleep, but cool. I'm not confident. Getting confidence at mathematics. I guess try some easier problems. I'm always telling people to try tricky problems, but try some easier problems as well. Go back to stuff that you were doing a year ago, and you will hopefully find that you're better at it. Even if you haven't thought about those topics, all the kind of other skills about solving problems and having ideas quickly and acting on ideas, you go back to stuff you were doing a year or 2 years ago, you'll find that you're much better at it just on speed and knowing the right answers without really thinking. I think that might be a confidence boost, that you are capable of getting faster at maths, getting better at having ideas, getting better at changing your ideas as you go along. You're just meeting new content, and new content is always tricky to take on. That keeps happening, especially at degrees. We give people lots more content, and it's tricky because it's new content. But they do also get better at solving problems and the kind of transferable skills. Maybe you don't notice if you're always working on new content and tricky problems. Which college do I work in? I don't work in any of the colleges. I have sometimes interviewed for some of the colleges, and I've sometimes done tutorials for some of the colleges, done some teaching, but at the moment I do not have a college. Right. Is it more important, somebody asked ages ago, here's a good question, I like this one. Is it more important to be really interested in maths or really good at it? I'm going to pick really good at it out of those two. Do some colleges require an at-interview assessment? I think the answer is yes. Some of them do give you some questions to look at before the interview, and then during the interview talk about those questions. So I think the answer is just yes for that one. I'm not sure if they're still doing that during online interviews. Maybe the answer is no. Maybe. There you go. There's a safe answer. An interesting question that's just come in. Are lecture times fixed, or do they vary from day to day? So they're almost all in the morning, but then the lectures would be, so I think vary day to day is the best thing I can say. That rather than turn up at this time, you'll be given some lectures and then leave like school, there might be one course that you're doing that's on Tuesdays at 10 o'clock, and you every Tuesday at 10 o'clock you turn up and do that course, and there's a separate thing that you're doing at Thursdays at 9 o'clock. You also turn up for that one, and those are at different times on different days, so that they're not going on simultaneously. Those are at different times, different days, but it kind of works a bit more like that with the timetabling. I'm not quite sure if that answers the question. Who do I know from the CS department? Oh, I'm not gonna name people I know from the CS department. I think that'll just be embarrassing for me and for the CS department. I mostly work with the admissions people in computer science. Good, right. Living costs has just come in. How do I unflag that one? Interview questions, just checking my starter questions as well, things that I flagged along the way. Best personal statement point-wise. Oh, B posted that problem. People talking about the problem. Rilo likes the problem as well. Good. Book recommendations for discrete maths was Ali's other question that I didn't have anything for. How long do you spend on the personal statements? Oh yeah, this one was a really good question as well. I always say that 70 to 75 is a good score, and I stand by that. I think it is a good score. The median scores of people being interviewed or receiving offers are often less than 70. It's gone that way around. What do I make of that? Is getting less than 70 not a good score? Not rule you out. Does not rule you out. Because it's not a hard cut-off on the maths. We don't have a sort of pass mark where we interview people and we don't interview people. We look at the rest of your application. In particular, we look at your previous grades, your predicted grades, and your personal statement. And we look at your teacher's reference, and we look at the context around how you applied. We look at the context around your education. We're interested in all of that, as well as your maths score. And that makes the boundary a little bit fuzzy. Yeah, and somebody's asked the opposite question immediately underneath there, which is why do some people who get high scores on the MAT not get interviews? And that's sort of the other way around. That we've only got a certain number of people we can interview, so rather than just interviewing the people with the top MAT scores, we choose to interview some of the people with lower MAT scores, but contextual information around that, or other stuff that makes us think they had a bad day on the day of the MAT, but otherwise show loads of potential. That means we don't have to interview all the people with high MAT scores. We usually do interview all the people with really high MAT scores. Right, Alex, is that a new name? Have I seen Alex before? Hi, Alex. Do you know resources more abstract skills for like breaking down and finding patterns? Yeah, recognizing the maths that you're going to use. I don't really have good specific resources for learning those transferable skills. I sort of think you have to, maybe this is a personal philosophy, but I sort of think you have to pick them up by doing the questions and coming across those things, like the muscle memory of repeatedly coming up against, I've got to recognize what to do here. Oh, it's circles again. I've seen circles before, draw some circles. I can use the visual parts of my brain to recognize bits of circles. You know, I don't have the way you find patterns is you spot the kind of meta pattern in your patterns, but I don't really have advice like that. It's a really good question. It's a very important skill to have. I don't have a kind of watch this one video and you will know how to solve the problems. I think everyone I've seen who's teaching people to solve problems is basically just, here are some problems, let's solve them, and then think critically about how we solved them. I guess that's a step we're not quite doing on the live stream so much, of thinking critically back to what we did to actually solve the problems. I liked it when someone earlier said what they were thinking of doing in this problem, that was kind of critical to draw the picture and then see where the area is. And once you see it, then thinking about how it's made. So the class sizes, okay, really good question, Alex, thank you. The class size is all of us. We put all of the first year students together in their lectures. They all watch the same lectures, and then they have small group teaching. We call them tutorials, with just 2 or 3 students usually. Just 2 or 3 students, one tutor, talking with them on some homework problems. So in some sense, the class size is everyone, 200 people in the same lecture. But we also do these small classes looking at homework problems with 2 or 3 students. Tutorial, small group teaching. We think it's really important. I should mention it more. And Ali suggests Enrich as a good website for finding other questions, right? But that's a suggestion of more problem solving. Where are some problems to try? Yeah, okay, Ali, if you've seen an interview question before, then please, you can say that you've seen it before, is the right thing to do. And then that's fine. We can make it harder, or we can tweak it a bit to see, do you actually understand how this question works? Sometimes people say that they've seen the question before, but then it turns out that they haven't actually seen the question because I'm doing something different. So it's okay to say that you've seen it before. We can usually tell when someone, especially if they've not quite worked out what the question is and they think they've seen it before but they haven't really, we can usually tell when someone's repeating something they've seen before rather than actually doing the maths, if that makes sense. I think we can tell. And also, often people are wrong. They think they recognise the maths, but it's actually a different question, and then they're reciting something that doesn't match what I've actually asked them. Anyway. So tutorials are a small group with 2 or 3 students, 1 tutor. Might be the lecturer, or it might be a member of staff from one of the colleges, someone who's a researcher maybe, or someone who's there to teach, going through problem sets, going through problems that people have been working on. So the lectures have happened, everyone's learned the content, and they get set some homework problems to try, and then the tutorials go through those homework problems with the group of 2 or 3 students. They hand in some work that gets marked, and we go through it. So it means, as well as the big lectures, we're also catching up with our students in these small groups to catch up with how they're doing on each of their courses. We organise tutorials for each of their courses. So I might sit down with some students who've been studying differential equations, the small bit of course, and we'll talk about differential equations and some questions that they've been trying. And they'll say things like, I don't really understand this bit of the lectures, can we talk about it? And then we'll talk about it. Or I might say, you've done this question wrong, we're going to talk about it, and then we talk about it. It's an important part of the Oxford teaching method that we've got the lectures, but then we've also got tutorials in first and second year. Riser says, what did I miss? Like 2 hours. I'm going to wrap up very soon. But really good questions, everyone. Thanks for asking them. Let's do the whole thing again. 2 hours, let's go. 7 to 9. If you get like 90 plus on the MAT, you are, oh gosh, I worked this out at one point, you were like 95% to get play, or is it 95? It's pretty likely that you'll get a place at Oxford. 90 is really good on the MAT. Good. And then the kind of combo question of, if I get 95 on the MAT but not the predicted grades, can I get interviewed or get in? This is the question, we've had this question quite a few times, right? If I do amazing on the MAT but my teachers say that I'm not going to get the grades in school, then that's very strange. We're quite interested that you did so well in the MAT. We're a bit concerned that your teachers said you're not going to get the grades in school, but it's possible that we'll interview you and make you the offer to get the grades, prove your teachers wrong, get the grades, and then if you prove your teachers wrong, then you start the course. B and Rilo are now talking about the question. Stick or twist or something about bullets. Who knows? Okay. I might look up what they're talking about at some point, but not right now. Okay, B gave us a link in chat earlier. Okay, I'm going to answer some more of the questions by typing, but I'm going to stop being live now because, goodness, we've been live for 2 hours. Getting longer each time. I like the just chatting bit though. Just chatting bit's fun. And we did slightly more maths, so that's good. My mouse is broken, so I can't actually stop. There we go. There are other parts too to B's problem. Rilo came in hot with the suggestion about what to do, and now other parts of the question are going on. Always more mathematics. Right, cool. See you all next week for, gosh, I think it's graph sketching, curve sketching, drawing some graphs. I'm going to draw some pictures. I imagine that's going to go very, very well. I'll see you next week. Have a nice week. See you in 167 hours. Bye.